basic fundamental of the signal characteristic. Yes. Hello. Yes. Any issue? Any new thing that you want to share with me?
No, sir, but can you send the PPT files?
Your voice is breaking. I'm not getting your voice properly.
Sir, can you send the PPT files?
Your voice is not clear still. Can you
I will send
arrange
it.
yourself in some place where the good connections? Hello. Yes. Hello.
Yes, sir. Yes, the connection is not good.
Hello. Um, your voice is breaking. Can you repeat what? Or you can type in a chat box also. You can type your comment in chat box also. Hello. Okay. Okay. About the PPT files. Okay. 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 I will send the PPT file in a Canvas account. And I think you have decided to create one WhatsApp group also in which I can share all the information. So if you have already created, then add me. Otherwise, I will say, upload it to the Canvas so you can read this PPT and you can refer the previous topics and you can revise whatever the things that we are discussing right now. Okay.
Okay, sir. شو الأخبار أحمد داوود؟
كده أبو حميد.
لك حاجة يا زلمة والله ملينا.
هلا
زمان
خلصت
يلعن أخي.
المحاضرة.
هلا ده اللي بدأ يعملنا، ده اللي عمل شير للسكرين وبلش.
لك أبشر أبشر يا شباب.
كريم امتى بدهم يوقفوا هذول؟
أنا ما حيوقفوا.
ما شفت بعتين على
نعم.
التليجرام تليفون، بعتين إنه راح يعملوا ريكورد للمحاضرة واللي شو اسمه بصورة بيشوفها.
حلو.
يعني ما بفهم ليش هيك هن جحاش.
إذا بدنا نحضر برمج ما بدنا هيك.
هذا الجحش وين راح؟
صديقي لا تغلط لأنه هاي المحاضرة بتسجل.
Where is the doctor?
تعالوا نطلع كلنا،
Hmm?
نطلع كلياتنا، يرجع ما يشوف حدا.
حاولوا هلا بيجي.
جتنا الفرصة كان لازم نستغل.
اللي بعد داتا ستراكشر معك.
ايه
بتعرف شيء اللي هي اللي عم تعطينا ولا لا؟
لا، هي الدكتورة جديدة. هيك بظن يعني.
خير خير. بس هي لو تبطل لي تبعت هلو كل 5 دقايق تقول لك هلو.
صح مو بس هلا وياس وفهمانين ومدري شو، بدك
كل
تضل
خمس
عم تحكي
دقايق
معه.
كل دقيقة بعدين بدك تبل فاتح المايك يعني.
Hello, is
هلو
my
سير.
voice is audible? Oh, okay. It's a little bit interruption. Network was gone suddenly, so I'm again starting. Let me present my screen so you can see the topic that we have discussed in last lecture. Yes. So, in our last lecture, what we have discussed about the signal characteristic. We have started with the basic of analog and digital signals. Then we have seen about the periodic signals, aperiodic signals. We have also discussed about the bandwidth, which is associated with the periodic signal, and bandwidth, which is associated with the non-periodic signal. As well as we have discussed about the little bit about the digital signal. And in the digital signal, if that is uh, two-level system, four-level system, depend upon the number of beats per second, how that digital signal is going to be represented. As well as we have discussed about the uh, data rate to transfer the any particular file or to transfer the particular page. So what is the bandwidth that required? We have also seen one example of HDTV and bandwidth requirement for such HDTV. And we have ended our last lecture with the one particular topic name, which is as a compression. In the last lecture.
إيه إيه.
خلاص خلونا نطلع. شو هالمحاضرة هاي؟
لا يا رجال شوية لازم تخليه يقعد يحكي لحاله يعمل محاضرة حاله. هذا شيء سمعتنا سيئة عندهم يا زلمة. هذا له هاي
طيب
بتضل
ليك
نايم يا رجال.
نظامي على آخر الحكي.
جيتكم يا الربع. عيسى ما سافر؟
مين مين سافر؟ مين سافر؟
ما سافر؟
لا والله موجودين هون. ما بروح بلاكي.
يا عيني.
مدار صديقك، انت كيف عم تفتح منك؟ إذا كتر ما النت عنده سيء ما عم يسمعني.
I am audible. Hello,
Yes sir.
Karim, Muhammad.
Yes, sir, yes.
Now it's creating a problem. It's suddenly it will kind of the make me out from this meet, so it will create problem.
No.
Happen with you or it's happened with mine only?
No, sir, it doesn't happen with it.
Oh man, I don't know why it is happening. When I start presenting my screen, it will create a problem.
Sir, we can take the lecture without screen.
لا إله إلا الله. شو المحاضرة اللي معته؟
يا حرام.
أحمد داوود بدينك وأنت مهكر له النظام وعم تطلعه.
لكن بدي أسألك نفس السؤال، بيكون حسن نعمان عصب وهكر وطلعنا.
حسن أمان نايم، صار له 3 أيام نايم.
لا أنا فيقو فيقو.
فياته قال لي لا يا زلمة بموت.
لا
Hello, Tim, is that audible? Muhammad?
Yes, sir. Hello.
Okay, now I think it's okay. I have changed the
Yes, yes.
browser, so might be now it will allow us to do the actual.
Okay.
Your voice is still breaking. Am I audible to clearly? Audible to you clearly? Okay. Is that PPT is visible to everyone? Hello.
Yes,
Okay.
sir.
Okay. That's good. That's good. Okay. So yes. Yes. So what we have discussed in the last lecture that whatever the signals, two type of the signal we have. First is going to be analog, second is going to be digital. And we have also discussed about the periodicity. If signal is going to be periodic, then how their frequency response was. And if this signal is going to be non-periodic, then what are the frequency response of that particular signal. So over here, we need to take the example of the digital signal, and we need to identify that, like if you are having a time and frequency domain, if you want to identify for the digital signal. And so obviously if that signal is going to be periodic, and if it is going to be digital, then we can say for the periodic signal you are getting a frequency response which is a discrete frequency response you have. So over here you can see that in this particular signal, the signal is going to be periodic. So obviously that frequency response is going to be discrete. While we can consider like that only single pulse if you have in your particular system, or we can say in particular your communications, if there is only one signal is there and that signal not going to be repeated after that, so we can say that signal is going to be non-periodic, and that non-periodic signal is going to be considered, or it's going to be present as a continuous frequency response in the frequency domain analysis. So there is just an example like that. If you are having a periodic digital signal, their frequency response is going to be discrete, while if you are having a non-periodic signal, then their frequency response is going to be continuous. Is that okay over here? Can you give your feedback? Is that
Yes, yes, sir.
hello? Okay.
Yes, sir.
Yes, it's
Okay.
okay, sir.
Okay. So I will move forward. So we can say over here there is one funny picture we have, like why we need to worry about the signal and the channel bandwidth. Like we can say whatever the capacity of your channel you have, and according to that channel capacity, if you have not decided the proper bandwidth which is associated with that, like you are having the capacity of, let's take 1 gigahertz, or we can say your capacity of your channel is having, let's take 1 gigahertz spectrum, 1 gigahertz bandwidth is there. But if you are inserting 3 gigahertz signal in that same channel, so we can say it is considered as overloading, and effective communication not going to be it's not going to be happen. So always we need to think about that the signal and their channel bandwidth. Whatever the signal we are considering, we also need to consider what is the bandwidth going to be acquired by that particular signal. That is the most important part we have, and then on that basis we need to discuss kind of the next slide that we have. Now let's consider we have like we are having a baseband transmission. The topic we need to discuss over here. That let's consider that the digital signal, which is made up of composite analog signal with infinite bandwidth. As we have discussed in this slide, like if you are having a digital signal, so we can say the band required or amount of frequency which is associated over here, which is kind of the infinite in manner. We can say so many frequency components are there in such a digital signal. Over here also, if there is a non-periodic only or periodic only, but it required either continuous or discrete bandwidth, but the bandwidth requirement which is going to be very large. Simply we can say if you are having a digital signal, it required a infinite amount of the bandwidth. Over here also you need to understand like that whenever we are squeeze the signal in one particular domain. Like if we have squeezed our signal pattern into the time domain with the such type of the box or such type of the kind of the pulse, which is, well, let's take it's a square pulse. So obviously, as per the discussion we have done previously, their bandwidth is going to be increased in an infinite manner. So whenever we are sending the signal of a digital, it's necessary required to have the infinite bandwidth of your particular channel, which is look like a quite impossible way. So that's the thing is discussed over here, like in digital signal, which is composite of the many analog signal, which is required infinite bandwidth. Well, we can say if we are having a baseband transmission, which means that sending a digital signal over the channel without changing the digital signal to analog signal. Like we can say if you are transmitting your digital signal into the channel, so what do you mean by baseband transmission? You are not going to change the shape of particular digital signal, and you are sending that same thing by superimposing on to the any analog signal, and the shape is going to be same at the receiver side. So we can say baseband transmission required a low pass channel. So over here we need to find out the solution to incorporate like the signal, digital signal, which required the infinite bandwidth. We are sending this signal in a such a manner that it going to be sent successfully with the very finite band of the operation, or with the very finite band of the channel that is required to transmit such an infinite signal, infinite band signal. So that is our primary requirement, and that is going to be done by the baseband transmission. So over here we have a two type of the channel we have. First one, which is going to be wideband. Second is going to be narrowband. So from the name itself, it is suggested as a wideband. It means it is having very wide bandwidth, while in the narrowband, it is having the very narrow bandwidth. So over here, two computer is shown over here. So one computer will send the digital signal into one particular channel, and our primary target is to send a same type of the digital signal to the receiver side, and signal should not get discredited, or we can say it's not going to be degraded. That is our primary requirement over here. So we can say like that, what do you mean by wide channel, and we can say what do you mean by narrow channel, or we can say wide bandwidth or narrow bandwidth. So if that bandwidth acquired by the particular channel is going to be very larger, then it is going to be a wide band signal, or we can say wide bandwidth type of the spectrum. And if it is having very narrow band, in the frequency spectrum, we can say there is a bandwidth type of the spectrum we have. Over here, this diagram we need to understand very clearly, and this is the basics of like why we are choosing a modulation technique and why it is required. So over here we have mentioned one digital signal which is having a two level. One is going to be higher, one is going to be lower. So over here there is a digital signal is there, and which is a non-periodic over here. You can see like that there is a non-periodic signal. Same shape is not going to be repeated after some time. So we can say non-periodic signal. So first you need to keep in mind that non-periodic digital signal, it means the bandwidth required which is going to be continuous. So over here it is a continuous bandwidth shown over here, and over here it is mentioning that it is a 0 to infinite bandwidth. It means, as we have discussed, like if you are having a square type of the digital signal, such a digital shape of the signal you have, so that digital signal require the infinite amount of the bandwidth to acquire that shape in the frequency domain. But whenever you are having a channel, so channel always having some limited band, like f2 minus f1, let's take a 20 megahertz, 30 megahertz. So band is going to be limited. So bandwidth supported by of the medium which is going to be limited, and if you are sending such an infinite bandwidth required signal to the finite bandwidth of the channel, so we can say the signal which is going to be received, which is going to be also suppressed to the such amount of the frequency, which is bound between f1 to f2, which is nothing but the channel capacity of your particular channel. Okay, so according to the channel capacity, your infinite bandwidth signal is going to be squeezed into the finite one. So if the signal is going to be finite one, and if you can again identify the time domain analysis of that, over here we have gone from time domain to frequency domain. Over here, if we can back from frequency domain time domain, we can say like that finite bandwidth signal will change the shape of the digital signal. So we have sent this signal over here, which is a very much sharp, but due to this particular finite bandwidth, you will receive the signal which is not going to be such sharp, and the shape is going to be change over here. So this thing is going to be happen. Over here, any doubt or any question? If you have not understand this diagram, or if you have not understand anything over here, can you give me the confirmation? Is that okay?
Clear, sir, clear.
Okay. So what this diagram also, another diagram is showing, which is nothing but the rough approximation of digital signal using the first harmonics over here. So what it will says to us, like it having kind of the three frequency component we have: 0, n by 4, and n by 2. Okay, so its n is nothing but which is going to be your bit rate n, and bandwidth we have decided which is going to be n by 2. So let's consider if you are having a bit rate which is going to be n in all the shape, but if we can say f is going to be 0 and p is going to be 180, as well as this n is going to be n by 4, or we can say it's going to be phase is also 180, then n by 2, then n by 4, likewise. So what is the meaning of this all particular stuff? Let's take over here that your frequency is going to be 0. So frequency going to be 0, it means there is a straight line, you can say, which is going to be considered as a 0, 0, 0, because that frequency is going to be 0. Well, if you are putting frequency equal to n by 4, so if you are putting a frequency equal to n by 4, we can say according to the n by 4, your analog signal is going to be created like this one. Like this, what is n by 4, n by 2, we have discussed during the periodic signal and analog and digital signal comparison. So if your is going to be n by 4, so we can say according to this signal, your digital signal is going to be created like 0, 0, 1. If it is going to be n by 2, if it is going to be n by 2, but phase right now it's also going to be 180. So if it is a n by 2 frequency, then the shape is going to be changed like it's n by 2 is a one complete cycle, then there is a half cycle. Over here there is a n by 4, it means in entire structure your only one peak is coming and another peak is going to be half. Up to the half it will reach over here. Similarly, if you are having a n by 4 same, but your phase is changing from 270. So we can say whatever the 180-degree signal you have, now it's going to be shifted to the 270. We can say it's a 90-degree shift we can observe between second one and third one. So if we can observe the 90-degree phase from second one and third one, so you can say 001, that is shifted to 011 in the digital bit rate. Likewise, if you are having a n by 4 with the p equal to 90, p equal to 0 with the n by 2, or we can say p equal to 0 with the n by 4. So according to that, whenever you are choosing the different frequency component, either n by 4 or n by 2, you can get the different type of the digital beat pattern out of that. That is the thing we need to discuss over here. So in between there is my screen is not visible. Let me again share my screen. Now is that visible? My screen is visible. Is this PPT is visible?
Yep, it's visible.
Yes, yes,
Yes,
sir.
it's visible. Okay. Okay. So what is the thing over here that we can discuss over here? If you are having any digital signal you have, let's take if you are having a digital signal having such discrete components 0, n by 4, n by 2, 3, n by 4, 3, n by 2, 5, n by 4, 5, n by 2. So if your bandwidth is going to be increased, okay, if your bandwidth is going to be increased and that discrete component which is associated with that individual frequency component, if it is also going to be increased because that bandwidth is changing from n by 2 to 5 n by 2. So what we can understand from that, whatever the digital signal, let's take with the bit rate of n, let's take there is a 010 signal you have. In the analog, this is going to represent like with not as a same shape, but it is going to be that shape is going to be degraded. So we can say in digital bitrate, if it is going to be n, but in analog it is going to be n by 2 and 3n by 2. So what is the meaning of that? In the digital signal, whatever the bitrate you have chosen over here, which is a n, but if you are representing the same signal with the analog frequency, so we need to identify the different discrete frequency component to accomplish the same type of digital signal. If now if you are not choosing the different frequency component, like if you are adding the n by 2 and 3n by 2 signal in your frequency domain, then it is going to be created the digital signal like this one. But if you are choosing only frequency f equal to n by 2, so such type of the analog signal is going to be created in your system. Like if you are adding more number of the frequency component, one from n by 2, one from 3n by 2, one from 5n by 2, if you are adding the different type of the signal, so your shape is going to be changing like that. So it means that whatever the digital signal you are representing, which is as simple as a bit rate of n, but to accomplish this same shape, we required a multiple frequency component to adding adding in the original system, and it will create the shape which is looks similar to this digital one. Because as we have discussed in the last lecture, that if your signal is going to be periodic, then, and if that periodic signal is going to be there, obviously there is a multiple frequency component which is associated over that. So what do you mean by the multiple component? Here it is showing the reverse process of that. To accomplish this digital shape, we require a multiple analog frequency component which can satisfy such type of the square shape. That we need to discuss by comparing the digital signal and analog signal, bandwidth and all stuff. Okay, so that thing I want to convey you, that what do you mean by the infinite frequency we require to accomplish the digital signal? Because by adding such a different frequency component, discrete frequency component, you can ultimately reach to the digital shape of that. So as we can see, there is a multiple frequency component required. It means whenever you are sending this signal over any channel, so you require a very large bandwidth, because that shape is made up from the multiple frequency component over here. So over here there is one baseband transmission related to that. What is a bandwidth requirement to satisfy the digital bitrate? Let's take it's for the 1 kbps. So first harmonics we require 500 hertz. If you are sending with the first and second, if you are accomplish the two signal, then it's required the 1.2 kilohertz. If you are accomplish the 3 signal to satisfy the same bit rate of the digital, we can say it's going to be 2.5 kilos required. So we can say if we need to send the bit faster, we required a more and more bandwidth, okay, to associate such particular bit rate. Now, if that bit rate is going to be 100 kbps, if you are sending with the 1 harmonics, 2 harmonics, or 3 harmonics, we required a 50 kilohertz, 150 kilohertz, or 250 kilohertz of the bandwidth when you are transmitting the higher bit rate of the signal. Okay. Is there any difficulty and doubt over here if you have not understood anything or in any particular problem? Any issue?
No, sir.
Okay. So over here there is some of the example, like we can say what is the required bandwidth of the low pass channel if we need to send a 1 Mbps by using a baseband transmission. So obviously that identify by the twice of that particular frequency that we are choosing as a baseband. So our answer is going to be depend on the accuracy decided. So we can say minimum bandwidth we required, which is equal to the bit rate divided by 2, which is going to be 500 kilohertz. We can say if you want to send a 1 Mbps speed of the low pass channel with the 1 Mbps speed, then we required the bandwidth of that particular baseband signal, which is having a 500 kilohertz. If you want to send it more, or if you want to send it with the very clear type of the shape, like as we have discussed over here, the shape is going to be changed with the 1 harmonic, 2 harmonic, 3 harmonic. If you want to send it a signal very proper in manner, so that 500 kilohertz going to be multiplied with 3, 5 and so on. So if you want to send more and more accurate type of the signal, then we require the bandwidth of 500 kilohertz, 1.5 megahertz, 2.5 megahertz. Likewise, the bandwidth you require if you are increasing the harmonics of your particular system. Another example we have, like we have a low pass channel with the, let's take 100 kilohertz of the bandwidth. What is the maximum bit rate of this channel that we require? So what is the solution suggested over here? The maximum bit rate can be achieved if we use the first harmonic. The bit rate is going to be twice, 2 times the available bandwidth, or it's going to be 200 kbps. Like if our low pass channel bandwidth is going to be 100 kilohertz, the maximum bit rate of our channel that we can send as a 200 kbps. So it's a reverse, like whatever the channel bandwidth we have, according to the twice of that particular twice of that bit rate, we can send it to our system. Now, if the available channel is a band pass, we cannot send the digital signal directly to the channel. We need to convert this digital signal into the analog before the transmission, and this is known as a broadband channel. Now, what do you mean by broadband channel? Like there is one of the particular band pass channel which is having a starting frequency f1 and kind of the ending frequency f2. So what we need to do that before sending to a channel, to accomplish this bandwidth requirement, what we are doing, whatever the digital signal we have, first we are converting this digital signal into the analog, and then that analog signal, we know that if you are having an analog signal, bandwidth requirement is very going to be limited. Like if I'll go just a little bit earlier, you can say like that, if you are having any particular analog signal, you can say the bandwidth requirement very lower, only 1 peak we required, and if more analog signal you have, we can say some of the band we required. So if we can convert our digital signal somehow into the analog and information is sustained as it is, so we can say the problem which is created over here about the bandwidth requirement, that we can resolve. So what ultimately we have concluded over here, if you want to send your signal without the distortion, and if you want to take care of your channel capacity also, so obviously we need to convert our signal into the analog, digital signal into the analog, and then we are sending to the band pass channel, and the effective communication is going to be take place. So this is a last diagram that I need to discuss over here, and then we will go with the question answer or interaction with you. Like this is an input signal, digital signal we have. What we are actually doing in our communication, this digital signal is going to be transmitted. This digital signal is going to be transmitted or transferred via digital to analog converter. In digital to analog converter, this digital signal converted into this some analog waveform. While in analog, what is going to be changed over here? While you are having a higher pulse, or we can say when you are having a higher voltage, amplitude of the analog is going to be higher. If you are having a lower voltage of the digital, your amplitude is also going to be lower. So you can observe over here, whatever the shape of the signal is going to be there, that shape is going to be superimposed in the amplitude of your analog signal. And as you know that if your analog signal you have, then the bandwidth is also going to be limited. Okay, because in analog signal, which is nothing but the sine wave, so which is a bunch of sine wave which is created such type of the shape, so bandwidth requirement also going to be limited. So after sending this limited signal into the available bandwidth of f1 and f2, you can again retrieve this similar type of the band over at the receiver side. And once you will get at the receiver side by applying the reverse process over here, if you have applied digital to analog converter, over here if you can apply analog to digital converter, again you can retrieve this similar type of the signal in the receiver side. So by adding this particular component, digital to analog and analog to digital, by placing these two components, whatever the bandwidth problem we have, like infinite bandwidth required to send the particular signal, which is going to be reduced to the limited bandwidth. Okay, so by placing these two components, it is simply your bandwidth also, it will not degrade your signal also, and actual signal whatever you have transmitted, that you can receive at the receiver side. So that is the thing we can achieve when you are using a band pass channel and when you are using a modulation of the digital signal. So that is the first use that I have explained to you, that is a requirement of the modulation. Like why modulation we require in the digital. So answer should be like, we can save the bandwidth and the shape of the signal, which is also going to be maintained as it is, and signal will not going to be degraded. So by doing the analog to digital and digital to analog conversion, your effective communication can be take place. Is there any doubt or any confusion over here? You can ask, then I will move forward. Any doubt?
No, sir.
Any doubt?
No
Yes.
doubt. No doubt, sir.
Your voice is breaking. Yes.
No doubt, sir. No doubt.
Yes, Karim.
Yes.
Your voice is breaking. I'm not able to listen you. It's your voice is fluctuating.
Sir,
Can
I
you
told
type?
you that there is no
Can you
doubt.
type in the chat box so I can give the answer in that? Other students can also type their question and their query in the chat box because that audio is not coming properly. Karim is saying everything is good. So what I can say like that, can you please start your webcam, because I want to see your face, and I want to ask the question to each and everyone so I can identify whether it is conveyed properly or not, or you are getting all the information or not. So Ranim, can you start your webcam, please? Hello. Hello. Yes, Ranim. Ahmad Daud. Can you start your webcam so I can ask the question to you, please? Hello. Karim, can you start your webcam?
One
Hello.
minute, sir.
Yes.
1 minute. 1 minute. 1 minute. My internet connection is not that good.
Your webcam is not working. Okay. So we will ask in the audio, not in the video. It's okay. Let me ask to let's take Isa. Yes, Isa. Can you start your mic, please? Hello, Isa Abbas.
Yes, sir.
Yes. Are you able to listen to me?
Yes.
Okay. Isa, can you tell me what is the bandwidth of the non-periodic signal? You can type in the chat box also. If your mic is not working, you can type in the chat box also. What is the bandwidth of the periodic signal? Hello.
Yes, sir. Can you repeat the question, sir?
Yes.
Yeah.
Answer my question, please.
Can you repeat the question?
Let me write it in over here. Isa, question for the Isa. What is the bandwidth of periodic signal? Yes, question for Isa. What is the bandwidth of periodic signal? Question for Hiba. What is the difference between analog and digital signal? Yes, I have written your question in the chat. So you need to give the answer over there, so I can identify whether you have in line with me or not. Also, I will ask the question for the running.
Sir, I don't know.
Yes.
I don't know.
I want to ask the question to you, like what is the meaning of non-periodic signal? Yes, Ranim, you can give me the answer, or you can type over here, or you can speak also. What is the meaning of non-periodic signal?
Non-periodic signal?
Yes.
Okay, it's a period that doesn't have any signal at all. It's a be still period. Like it's.
Your voice is breaking, Ranim. Can you type so we can identify, because now due to the connection, audio is not coming properly from your side. If it is possible, do that.
Okay, I will write it.
Yes. Okay, yeah, you can write. Hiba, Isa, write down your answer in the chat box quickly.
No question for me, sir.
Kareem?
Sir, I don't know
Hello, Hiba, are you listening to me? Can you unmute your mic and can you tell me the answer if it is not possible in the chat box? Hello. Please give the answer, because we have only 5 to 6 minutes remain, and I want to take the follow-up also. Please give the answer quickly. Yes, it's periods that doesn't have the signal at all.
Sir, I will write for you.
Quite period, we can say. Yes, Iba.
I will write for you the answer.
You don't know the answer.
Yes, I know. I will write for you, sir.
You know the answer, Iba?
I will write it.
Okay, so you can type it. Oh, you are typing right now.
Okay, sir, I will write.
You can type it. So, Ranim, it's a period that doesn't have the signs, signals. We can say like that, Ranim. Meaning of the non-periodic signal, it means you cannot see any kind of the repeating pattern in your signal. Like we can say, as we have discussed in the PPT, like whenever we are having a non-periodic signal, we can say like that whenever you are observing the signal, you cannot find out any particular pattern. Like this one,
Okay.
you cannot find out any pattern, so we can say there is a non-periodic. But if you can find out such a pattern which is repeating after some particular time, that we can say it's a periodic signal. So likewise, you can, mostly I am getting your answer, but properly you can say like that. Is that okay, Ranim?
Yeah, it's okay, but I wish that you write the answers for us.
What am I not getting?
If you can write the answers for us.
Yes, I can write the answer. We can say if you can observe any periodic behavior or shape which is repeating after every time period, consider as the periodic. Okay, so answer, you can observe any periodic behavior or shape which is repeating after every period, considered as a periodic, and if it is not fulfilled, then it is considered as a non-periodic.
Okay.
Okay, So likewise, you can give the answer. Right
Excuse
now,
me, sir.
please. Yes, Hiba.
I write the answer, but I have a problem with letter N. So it isn't written. You can. In my keyboard, I have a problem with the letter N.
Okay, but right now, due to the audio, I am not
But I
able to
write down
listen.
my
You can
answer.
write
You
down
can
in
see it.
the chat box. Yeah, hello.
You can
Yes.
see the answer, sir. I write it.
You have written. Let me. Yes, Hiba. Yes, the major difference between both is that the analog signal that have the continuous electrical,
Yes.
while digital signal having the digital signal
Not
not a
continuous
continuous.
electrical.
Okay, you can say like that, like continuous time, continuous value, which is there is analog, while in the digital there is a no such a continuity is there. It's a discrete. You can say like that. Not continuous, you can
Yes.
represent as a discrete. So that's the better way to say the digital signal. Okay, instead of non-continuous, you can say like it's a discrete. Is that okay? Okay. So right now, please everybody write down your enrollment number over here and your last digit of your enrollment number, all the 7 students, and you can leave the class and you can join the other class if you have. Please write down your enrollment number, last 4 digits of your enrollment number, and then you can leave. Write down your 4 digit of your enrollment number. Everybody, please. Okay. Mr. Abbas has also written difference between its highest and lowest frequency component. It is the frequency range in which the signal spectral density is going to be non-zero. Okay. I have asked the question to Isa, what is the bandwidth of periodic signal? You can say like that, bandwidth of the periodic signal is going to be, that's the definition of the bandwidth over here, Isa. But you can say like that, the bandwidth of the periodic signal, which is represented as a discrete wave, infinite bandwidth, you can say. Discretized infinite bandwidth you have if you are having a periodic signal. Yeah, so everybody has written their name and enrollment number. I can see 3, 3, 6, and 7 students are there. Other. Okay, Hiba has also written. Now 3, 3, 6, 8 students we have. 9. Okay. So goodbye, and we will meet again in the next lecture. And I will tell you the next topic, and we will discuss your question answer in the next lecture. Bye bye.
Train